Lesson 2.3, Function Notation Notes. All right, guys, today we're continuing our talk about functions, and we're going to start with the idea of this right here, this thing that says f parentheses x parentheses. Okay, the way that I want you to read this in your brain, that says f of x. Like, that's how you read this. So you'd say f of x is the same as y. In other words, y equals and f of x equals, they're essentially saying the same thing, all right? But we look at function notation because it's a faster way for us to evaluate different values in our functions, okay? So let's go ahead and let's take a look at this first one. So we're given that f of x is equal to 7 minus 2x. Remember, this is another way of saying just y is equal to this, right? So it's just an equation. What we're going to look at is they want us to find out what is f of negative 4. I'm going to write that right under here. What's f of negative 4? Okay. Do we notice that we had an x in here, but now it's a negative 4? Right? It's going to do the same exact thing over on the right. So we have the 7 minus 2, except we can't write x. We have to be consistent here. Right? We see an x up top, so in the bottom, just like we did previously, we're also going to write a negative 4. Now this is just notation. That's another thing. We're not actually doing anything with this. Don't do anything with it. It's just notation. So I'm going to keep going over there on the right side. So this is really 7 minus negative 8, which of course turns into a plus. So here I get 15. Right? So we would say that f of negative 4 is equal to 15. And it's also fairly simple to do these in your calculator, right? I can take this part here and I can type it in over here. So 7 minus 2 parentheses negative 4 parentheses, right? We're just plugging in our x value, our negative 4 value, and we get 15, right? Again, super quick and simple to check. Let's go ahead and let's do problem 2. Same idea, right? This time it's d of t. Same thing as y equals, right? F of x, d of t. The next one's c of p. Guys, it's just notation. All right? Now, do we notice that we've got t inside of here? All right, and then they give us this equation, and they say find d of 1. So, asking for d of 1. So, this t is now a 1. So, on the right side, we're going to do the same thing. Instead of writing t, we're going to write something else. All right, t is now becoming the number 1. So I'm going to go ahead and I'm just going to put this right into my calculator to get my answer, right, to clean that up. So to get a fraction, I'm going to do alpha y equals, and just press enter. And I've got 4 on top and 5 on the bottom. All right, now I've got parentheses, 10 plus 15, and then another open parentheses with a 1 in there, close, close. Here we go. All right, my answer there is just 20. Problem C, same type of thing, right? Same type of thing. Now it's asking for it tells us C of P is equal to this equation, but now they want to know what is C of 18, right? So P has become 18. Well, we're going to keep going here, and we're going to say equals negative 12 minus 1/2 P, except just like over on this left side, P is becoming 18, okay? Now, you could do this by hand if you wanted. I just am choosing to put this in my calculator, okay? So I've got negative 12 minus, again, alpha y equals, just enter, gives me that fraction, so it looks just like my paper, which is comforting, right? Click over, and I've got parentheses 18 inside there. All right, and this is equivalent to negative 21. Okay, and that is my answer. We're going to move on to example 2. In example 2, we're still examining function notation, but we're doing it all with this graph over here on the right, okay? So the first question is asking us, what is f of negative 1? Remember how we used to say f of x? So really what we need to understand, that x right now is negative 1. So over here in our graph, x is negative 1, right guys? Here on the axis is where x is negative 1. But I need to find where on my function do I have a point where the x value is negative 1. And that point is going to be right here. Right? What's the coordinate of this point? That would be negative 1, left 1, up 2, negative 1, positive 2. So they gave me this, right? They gave me the negative 1. 2 is my answer. Okay, 2 is the thing that we had to find. So when I'm writing my answer to this, I would say f of negative 1 is equal to 2. Right? You can also think about this as the negative 1 was my x. The answer that you're finding is the y. Okay? All right. Look at the next one. Same type of thing, right? Now they're asking, okay, now x is 3. Right? Remember, f of x, but now they're saying f of 3. So over in my graph, where x is 3 would be here. Right? What's this point? This is 3 over 3 down to negative 2. They gave me the 3, so the negative 2 is my answer. All right, so when x is 3, the y value is negative 2. All right, so write a sentence describing f of 3. Basically, write a sentence describing my previous answer. And I'm going to say, when x is 3, y is negative 2. And again, that just explains kind of this previous answer we just talked about. All right, what is the x when f of x is 4? This one's a little bit tricky, right? Because we don't know the x value. This right here is the y value. So where do I have a point on the graph here? Let's change colors. Where do I have a point on the graph where the y value is 4? Let's see here. Well, if I go up 4, looks like here would be a point, right? Where my y value would be 4. What's my x value for this point? Well, that looks like it's just negative 3, right? They gave me the 4, so the answer to this question is the negative 3. So we're going to say x is equal to negative 3, right? That's the answer we were looking for. What is x? X is negative 3. Does the graph represent a function? And this one should be fairly simple, and we're going to say yes, it passes the vertical line test. Right? We talked about that for the last couple of days. If I can draw any lines on here, no matter where I draw them, none of those lines would be hitting twice, right? Passes the vertical line test. Okay, last but not least, flip this page over, and we're going to kind of see this kind of question in action here. Jack is reading his rough draft for his new book. The graph shows the total number of typos he has found so far. All right, so as he writes some of these chapters, the number of typos he's finding is going up. So we're being asked the question, based on this information, what is a reasonable prediction for the number of chapters Jack will have read when he finds 13 typos? So this is the information that I like because it's concrete. So I'm going to find on my graph where I would have 13 typos. Well, typos is this axis over here. And so here's 13, right? So where on this line would I expect this kind of data to hit? So I'm thinking I would imagine there would be a point right here, right? So this would be 13 typos. Well, how many chapters is that? That would be about 10 chapters, right? Remember, this is just a guess. We're just kind of trying to make an educated guess here. So I would say 10 chapters. Okay? So remember, function notation. If we say f of x, it's the same as saying y equals. And if we're given a question, like what is f of negative 1, that negative 1 is an x value. Okay, those are the two main points from these notes.